This is an interesting question. We have m sec theta plus 3 cos theta is equal to 4 sine theta. We're trying to get a hidden quadratic in tan. Now in this hidden quadratic, there's two m's, first of all, and there's a tan squared. Maybe the biggest giveaway is where the 4 is, because we've got 4 sine theta over cos theta, whereas over here we've got 4 sine theta. So the first step is going to be actually to divide through by cos theta, and I'm also going to show you why that will be useful and how tan squared can link into that. I mean, sometimes you just have to try things out, but if you can see this little bit I'm about to do, then it will help a lot. So sine squared plus cos squared is 1. If we divide through by cos squared, then haha, this is where we get tan squared plus 1 is sec squared. So right, that is how we're going to get the tan squared in this equation. So basically, divide both sides by cos, and sec theta divided by cos theta is actually sec squared theta, because it's 1 over cos theta times 1 over cos theta. So m sec squared theta plus 3 is going to equal 4 sine theta over cos theta, so 4 tan theta. Now let's replace this by tan squared. It might be at this point you spotted that. In any case, we're nearly there now. M tan squared theta plus m plus 3 is going to equal 4 tan theta. So m tan squared theta minus 4 tan theta plus m plus 3 is equal to 0. It's now given that there's only one value of theta in this interval that satisfies this equation, which remember we can turn into this equation. And given also that m is a negative integer, we're asked to find this value of theta correct to 3 significant figures. So what is this getting at? Well, it's a hidden quadratic here, so actually we're expecting to get two different values of tan. Tan in the interval, remember we're doing it from 0 to pi, so it's going to look a little bit like this. Therefore, to get only one value for tan, remember tan takes all values between 0 and pi. To get only one value means we can only get one solution for tan theta in the above, since tan takes all values in the interval 0 less than theta less than pi. Actually, strictly speaking, it never takes these two values, so it's non-zero. But that's not going to be that important. But the consequence is, therefore, the discriminant, sometimes written as this, the discriminant, which is b squared minus 4ac, must equal 0. And hey, you might not have expected that to crop up here, but this is what the question's getting at. So let's work out the discriminant. Minus 4 squared is going to be 16. So minus 4 times m plus 3 must equal 0. We've got ourselves a quadratic in m. 16 minus 4 m squared minus 12m is equal to 0. Rearrange. Divide by 4. Factorize. Going to be plus 4 and minus 1. So there's going to be two values of m that will lead to only one solution for theta in the interval 0 to pi. I hope I've made that clear. I hope my diagram is explaining that. Now, we were told that m is negative, So I'm going to reject this one, and we're well on our way now. We can put it back in to here. So therefore, minus 4 tan squared theta minus 4 tan theta, put minus 4 in here, minus 1 is equal to 0. So 4 tan squared theta plus 4 tan theta plus 1 is 0. Now we could try and factorize this, but you know what? We've already shown the discriminant is 0. So we can simply say that tan theta is going to be minus b, so minus 4, plus or minus 0, all over 2a. In fact, did I need to do all this? That's quite, maybe not, but I'm going to get minus a half. So theta is going to be inverse tan of minus a half. Working in radians. Gives minus 0.4636. So what we've actually found is this one here, but we want it in the interval 0 to pi, so I just need to add on pi, because that's the periodicity of tan. We get 2.6779. So I reject that one. Theta equals 3 significant figures, 2.68. Brilliant.